Hi again and welcome for another session of solving problems. Now what we're going to discuss is the head loss. We are given of a problem, a fluid having a V or viscosity is equals to 7 times 10 raised to negative 5 square meter per second. Flows in a 500,000 millimeter long pipe having a diameter of 25 millimeter. Determine the head loss required to maintain a velocity of 4.7 meter per second. Now the givens are viscosity, which is equals to 7 times 10 raised to negative 5 square meter per second, the length of 500,000 millimeter converted to 500 meters, and diameter is equals to 25 millimeter converted to 0.025 meters, and also our velocity, which is 4.7 meter per second. What we need to find is the head loss required. So to solve this, we have been given an equation of major head loss, or H sub F, is equals to friction factor times length divided by the length of pipe, multiplied to the velocity square divided by 2 times gravity. But in this equation, we have a few missing values. So first, we need to solve the Reynolds number. Through the equation of velocity times diameter of pipe divided by the kinetic viscosity. Now what we need is substitute our values to our equation and solve. And that should give us an answer of 1687.57. Now remember that when the Reynolds number is less than 2000, it means it is laminar. Next, what we need to solve is the equation for laminar flow, which is F is equals to 64 divided by the Reynolds number. Now we substitute again, and that should give us an answer of 0.0379. Now as we can see, we already have completed the values needed for our first equation. But remember that gravity is equals to 9.81 meter per second. Now what we should do is substitute and solve. And while we are solving, we need to remember to cancel units to ensure we have the right unit for our final answer. And as we solve, that should give us an answer of 853.43 meters. So therefore, the head loss required to maintain a velocity of 4.7 meter per second is 853.43 meters. Now that is all for our session. See you on our next videos.